Senior 1, how are you all? Today I'll talk about chemical formula. First, covalent compounds. As we know, covalent compound is formed of non-metal and non-metal by sharing electrons. First, I'll talk about number of repetitions. 1 equal mono, 2 equal di, 3 equal tri, 4 teta, 5 penta, 6 hexa. For example, for number of repetitions, boron trifluoride, boron P, trifluoride F3, so boron trifluoride BF3. Number 2, carbon tetrachloride, carbon C, tetrachloride Cl4, so carbon tetrachloride CCl4. Phosphorus pentabromide, phosphorus P, pentabromide Br5, so phosphorus pentabromide PBr5. Sulfur hexafluoride, sulfur S, hexafluoride F6, so sulfur hexachloride SF6. Nitrogen dioxide, nitrogen N, dioxide O2, so nitrogen dioxide NO2. Sulfur trioxide, sulfur S, trioxide O3, so sulfur trioxide SO3. Sulfur tetrachloride, sulfur S, tetrachloride Cl4, so sulfur tetrachloride SCl4. Oxyacids, oxyacids that acids contains oxygen and begins with hydrogen cation followed by negative atomic groups, considering replacing ATA by suffix IC. For examples, nitrate NO3. When I put a hydrogen begins with hydrogen, it's called nitric acid. For example, sulfate SO4. When I put H2 before or begins with hydrogen, it's called sulfuric acid. Nitrite NO2. When I put hydrogen cation followed by negative atomic group, it will be nitrous acid HNO2. Write the chemical formula of the following acids. Number 1, nitric acid. As we know, nitric acid HNO3. Number 2, carbonic acid H2CO3. Hydrobromic acid HBr. Hydroiodic acid HI. Chemical equation. Chemical equation is a group of chemical samples and formulas of reactants and products. Reactants, they are in the left side. Products, they are in the right side, which are connected together by an arrow that express the direction of this reaction and the conditions. Chemical equations properties. It's composed of chemical formulas and samples of the reactants and products. Both sides of the equation are separated by an arrow. That arrow describing the conditions and the reactions of the reaction. Number 3. It describes the number of molecules of reactants and products, and they must be equal each other. To verify the law of mass conservation. And it describes the state of reactants and the products. Solids denoted by S, liquids denoted by L, gas denoted by G, aqueous denoted by EQ. How to balance a chemical equation? To balance a chemical equation, we should make sure that the right side of the equation has the same number or the same number of atoms of the left side. Balance the following equations: Al plus O2, the products Al2O3. We must make a table that contains the products and the reactants and put the number of both of them in that table. In the reactants, Al just one atom, O2 two atoms. In the product, Al 2 atoms and O3 3 atoms. So first we will put 2 Al in the reactants to make sure that the number of aluminum in the product equal the number of reactant of the aluminum. In the product, O3, and in the reactant, O2. When I put 3 in the reactants of O2, it will be 6 atoms of oxygen. So I put 2 in the products to make the number of oxygen, or 6 in the both sides. When I put 2 in the product, aluminum will be the number of aluminum 4. So I'll put 4 in the aluminum of the product to be balanced equation. Balance the following equations. Number 1, KNO3 get KNO2 plus O2. When I'll make a table that contains number of products, number of atoms of products, and number of atoms of reactants, we'll find that the difference in the oxygen. In the reactants, we have 3 atoms of oxygen. In the product, we have 4 atoms of the product of oxygen. Okay, when I put 2 in the reactant of KNO3, we will find that the number of potassium will be 2, number of nitrogen will be 2, number of oxygen will be 6. So I put 2 in the reactants. In the product, I'll put 2 in KNO2. The number of oxygen will be 6 in the product. Why? 2 in KNO2. Well, the number of potassium will be 2, number of nitrogen will be 2, number of oxygen in KNO2 will be 4 plus O2. So the summation of the number of oxygen will be 6. Number 2, Na plus H2O gives NaOH plus H2. Number of sodium in both sides are 1, and number of hydrogen in the left side or in the reactants are 2, and the products are 3. Number of oxygen in both sides are 1. Okay, if I put 2 in the molecule of water, so the number of hydrogen will be 4 and the number of oxygen will be 2. So I put also 2 in NaOH. So 2 oxygen in both sides, and the number of hydrogen will be 4. To verify, the number of hydrogen will be in the reactants 2 times 2 equal 4. In the products, 2 times H from NaOH and 2 plus H2. So the summation of the hydrogen will be 4. But the sodium will be in the products 2, but in the reactants 1. So I put 2 and Na in the reactants. Number 3, Fe3O4 plus H2 gives Fe plus H2O. First, the number of iron equal 3 in the reactants, so I'll put 3 in the product. Number of oxygen equal 4 in the reactants and 1 in the products, so I'll put 4 in the H2O. So the number of hydrogen will be 8, so I'll put 4 in H2. Number 4, MnO2 plus HCl gives H2O plus MnCl2 plus Cl2. The number of magnesium Mn in the reactant and Mn in the product, so we have just one atom. Cl in the products we have 4 Cl. In the reactant we have just one atom. So first I put 4 in the reactants of Cl. So MnO2 plus 4 HCl. Okay, so we have number of hydrogen in the product equal 4. In the reactants equal 2. In the 4 in the reactants, but 2 in the product. So I put 2 and H2O in the product. 2. Okay, so Mn in the reactant and the product equal 1 atom. O 2 in the reactant and the product equal 2. H in the reactant and the product equal 4, and Cl also equal 4.